Welcome to EDU World Space.
In this problem, we have a bear that is standing on a platform here, and the bear is inching his way out to this basket of goodies that's at the end of the platform. The platform is supported by a cable that runs over a pulley that is attached to the wall, and there's a pivot here, and this cable keeps the whole thing from collapsing or from rotating around here. So we're told that the length of this platform is 6 meters, that the bear weighs 700 newtons, and the basket of goodies weighs 80 newtons, and then the platform itself weighs 200 newtons. And this angle between the platform and the cable is 60 degrees. And so we're asked initially if the bear is 1 meter from the pivot point, what is the tension in the cable and the forces at the support. And so we can take moments about this point here, and that will give us an equation in which we can just solve for the tension directly. So we have the moment from the weight of the bear, the moment from the weight of the platform, the moment from the weight of the basket, and then the moment from the tension in the cable. And I suppose I should label that here. Then we know everything, that has to be 0, so that this is in rotational equilibrium. We know everything in here but T, so we can plug in our numbers and we get the T is 343 newtons. That's this force here. Once we know that force, we can use force balances. In the horizontal direction, we know that F of x has to offset the x component of T. So F of x is 171 newtons. And F of y has to offset all these weights, and then it is help. It's also these weights are also offset the vertical component of T. That's why we have a minus sign here. So the force here is the total weight minus T sine theta, and if we plug in our numbers, we get that is 683 newtons. Now we're told that what happens if the maximum tension that this cable can support is 900 newtons. How far can the bear get out to this basket of goodies? So in that case, now we just have a different unknown here. Instead of T being the unknown, we have X. We know T, and so we can plug in T is 900 newtons, and then solve for x, and we get that x equals 5.14 meters, which is less than 6 meters, which means that at some point out here, this rope is going to break and the bear is going to fall. And it's kind of a cruel setup for the bear, because as he is just about to get to this basket of goodies, the whole thing collapses on him and he goes tumbling down. I guess at the bottom, when they all collapse to the ground, he'll get his food.